Hello everyone, continuing with the Good CET 2018 paper. In the previous video, I had taken up questions of matrices. In this video, we'll continue with the paper with questions of calculus. Here we are with the first question, and it is log e to the base modulus x. If base is e, it's easier to solve this, so we will change the base by taking it in denominator, log modulus x to the base e. So the derivative of 1 upon any term is minus 1 upon log modulus x here whole square, and applying chain rule, d by dx of log modulus x. And derivative of log modulus x is 1 upon x. So the answer is minus 1 upon x log modulus x the whole square. Now log modulus x, actually when we differentiated it over here using the chain rule, we had taken two ways, that is either it is negative or it is positive, because modulus x means negative or positive two cases. So when we take the derivative of this, then it becomes 1 upon minus x, and derivative of minus x, that is 1 by x, and this is obviously 1 by x. So in either of the case we get 1 by x. That's why we can write directly log modulus x's derivative is 1 upon x. In questions like this, we would rather think of substituting x as cos 2 theta, but then it should have square root. So here we will have to differentiate directly, which is 1 upon 1 plus x square and d by dx of applying chain rule. Take LCM and the derivative of u by v form. After applying the formula, we have 1 plus x square LCM over here, and this formula, that is u by v dash. Differentiate this, minus 1, and differentiation of 1 plus x is 1. So simplify that. This term will get cancelled. Denominator middle term will get cancelled. So we have 2 plus 2x square, 1 plus x into minus 1, and derivative of 1 plus x 1 over here. 2 common, and this is minus 1 minus x minus 1 plus x, and that leaves us with minus 2, and that will get cancelled with the denominator. We have minus 1 upon 1 plus x square. Now we have a parametric equation, and we want to find d square x by dy square. So first differentiate with respect to t. A as it is, derivative of t square, 2a as it is, derivative of t for y. And so dx by dt upon dy by dt, that is dx by dy is t. Differentiating again with respect to y, that is d by dy of t, dx by dy value, that is dt by dy 1 upon 2a. The important part in this question is just solving this part of the question. So I'm going to pick this up and solve it separately, which is e raised to log 2 raised to x square, e log being the inverse function of each other will get nullified, and we have 2 raised to x square. So put this here. Now our question becomes very easy, and e raised to x square dx. So let's take 2e raised to x square dx. And if we put x square as t, then x dx will become dt by 2. So that is 2e raised to t dt by 2. That's just like integration of a raised to x, which is a raised to x upon log a. Over here we have 1 plus log 2, that is we'll write log 2 plus log e, and then it becomes 1 plus log 2. In one of the 2019 paper which we have solved, in that also it was log e into some value wherein we split it up and we write it as 1. So in most of the CET papers, if you find question like this, you will come across. It's clearly visible from here that if we take x common, it is going to become x minus 3. So then we can combine the terms. So let's take common and then take LCM. X minus 1 upon x into x minus 3. Obviously, since the denominator is having factors, let us go with partial fractions, that is a upon x plus b upon x minus 3. So finding this by shortcut method, you close this term and put x0. So it is 1 by 3. So a value is 1 by 3. In the same manner, now you close this term and put x as 3. 3 minus 1, 2 by 3 will be the value of p. And that's it, we have our terms AB. Now let's integrate. So 1 upon 3 log modulus x plus 2 by 3 log modulus x minus 3. So if we want to take 2 by 3 common, we'll have to multiply and divide this by 2, so that 2 by 3 will be common. In the next step, we can take this half as degree and it will become log root x plus log modulus x minus 3. And we know log a plus log b is log a into b. 2 by 3 log root x into x minus 3. For finding the approximate value, let us use the formula f of x plus delta x is equal to fx plus delta x into f dash x. Let's first identify the function. Our function is x raised to 1 by 5 because it is fifth root of the number. So f dash x will be 1 upon 5 x raised to 1 upon 5 minus 1, that's minus 4 by 5. And x we will be taking 243 because the fifth root of 243 is 3. And delta x will become minus of 0.001. So that we have this term. So f of x plus delta x is this value, fifth root of 242.999, which is equal to fx plus delta x into f dash x. Now put the value of x, that is 243 raised to 1 by 5, which will be 3. And this will be 1 upon 3 raised to 4. Simplify this to find the answer. Here we have to find length of subtangent at a point of the curve log y is equal to 25x. Actually, this was a topic which was in the earlier syllabus of Gujarat board when NCERT was not introduced. So you will find this question in 2018 paper, and in 2019 a similar question is there. So for you can note down the length of the subtangent and length of the subnormal, which can be applied to find over here. So to find length of subtangent, we have to find first dy by dx. So we have dy by dx here. We have to find that. So it is 1 upon y dy by dx equal to 25. So dy by dx is equal to 25 into y upon dy by dx is, that's the length of the subtangent. So y upon 25y, which is 1 upon 25. So it is constant, proportional to y, 0 or proportional to x. Obviously it is constant. If you observe the good CET paper, you will find that some questions are similar every time. Like you have approximate value question, you have a question of integration, wherein you have to simplify in terms of E, and then you have an increasing decreasing question. You have a question of subtangent, subnormal. So many of the questions are repeated. I mean the topic is repeated, so you can do a similar topic and score well. Now here we want to find whether in which interval it is decreasing. In order to find increasing, decreasing, let us first find f dash x. So derivative of x, derivative of root term, 2 root, and then apply the chain rule, that is derivative of 1 is 0 and minus x is minus 1. Take LCM. And if this critical point is to be obtained, we have to equate f dash x to 0, and so the numerator will become 0. So we have root of 1 minus x is equal to half, squaring with the side, 1 minus x is 1 by 4, or x equal to 3 by 4. So that means our critical point is 3 by 4. In order to find increasing, decreasing, let us take a value smaller than 3 by 4, say half, and put it in f dash x. So we have 1 minus 1 upon root 2, which is positive because root 2 is greater than 1. So 1 upon root 2 will be smaller than 1. So this value is smaller, we subtract it from 1, it is going to be positive. So this is positive and this will be negative. And so the function decreases in 3 by 4 to 1. In order to find f of minus 1 here, we'll first have to integrate this function. So integration of f dash and integration of the right hand side. Integration of f dash and integration of f dash will become f. This is 2x and this is 5 into integration of x raised to minus 40x. So that becomes 2x minus 5 x raised to minus 3 upon minus 3 plus c. On putting f of 1 as 14 by 3, we will get the value of c. So put 1 here. Calculate to get c. Now f of minus 1 here. Minus 2 minus 5 by 3 plus 1. That is minus 6 minus 5 plus 3 upon 3. It's minus 8 by 3. In 2019 also we had a similar question. Now because we have x minus alpha here, we will adjust the numerator as alpha minus x plus x. Let's subtract and add x. So this becomes cos of x minus alpha, rearranging the terms. Now let's apply the formula of cos a minus b. Apply the formula and then separate the terms. So first term cos x minus alpha will get cancelled. You have cot x. In the second term sin x will get cancelled and we have cot of, we have 10 of x minus alpha. Let's integrate. Log modulus sin x plus log modulus sec x minus alpha. Or we can write it as log modulus sin x minus log modulus cos x minus alpha. And let's combine it. According to the option, we should write like this. Because we have two terms here. If we write sin x upon, we will not get it. Now we'll again have to put this formula. Again applying formula cos x minus alpha first let us divide with sin x. Let us take it separately. Cot x cos alpha plus sin alpha. And the next thing we will do is we will take cos alpha common. Now since this is a question of indefinite integration, we have plus c everywhere. Okay, I have not written it here since it's already there plus c in the question, but we already have a plus c here. Now see, we have taken cos alpha common, so sin upon cos becomes tan. And then we will separate this. Log modulus cos alpha minus, actually it is log a into b is log a plus log b, but because of this negative sign we have another negative sign here, and so it becomes like this. And obviously this will get combined with a constant, and we have minus of log cot x plus tan alpha. Cot x plus tan alpha. This is a question of the kind e raised to into, it is e raised to x fx plus f dash x, wherein our answer is e raised to x into fx plus c. But then it should be a simple term here. It cannot be cot inverse. So let's first substitute cot inverse x as t, so that the derivative is minus 1 upon 1 plus x square dx is dt. So cot inverse x is going to become t. X will be cot t. So we now have here cot square t minus cot t plus 1. And dx is actually 1 upon x square dx is there, and we have a negative sign here, or rather it is minus dt. So I'll write minus 1 into dt. Now let's see which of the following is a function. Cot square t plus 1 is cosec square t minus cot t into minus 1. So if we take this negative sign in the bracket, we will have cot t minus cosec square t, and that's good with our formula because this will be the function and this will be the derivative. Minus cosec square t is the derivative, so you can say plus of minus like according to this formula, and so our answer is e raised to t cot t. and put the value of t back. What is it? Cot inverse x. So e raised to cot inverse x and cot t is x into x plus c. Yeah, over to the next question. Here we have 0 to pi by 2 of x minus integer part of cos x. Now the value of cos x in this interval is between 0 and 1. So we have all values, or when we take integer part of this, it is going to be 0. Because we'll have like decimal value 0 0.1, 0 0.2 and the integer part is 0. So this part is gone. We just have to integrate x. So integrate x square by 2 it is. Put the upper limit and the lower limit. So when you put lower limit it is going to become 0. Putting the upper limit it is pi square by 4 and this 2. So pi square by 8. You can take it in this way, that squaring with the side, and that it is a circle with r square as 2 and so r is root 2. And we are looking only for 0 to root 2. That means from 0 to root 2, only this much. And y positive, so it's in the upper half plane. That means only one quadrant. The whole formula or the area of the circle is pi r square, but we are looking in first quadrant. That is why the area will become 1 by 4 pi r square. The value of r square is 2. So pi by 2 is our answer. Again a question of area of region bounded by the rays, but it is modulus x plus y equal to 1. So we can write y is equal to 1 minus modulus x, that is this values. Or if you want, you can directly write this is minus x plus y equal to 1. And the other one is x plus y equal to 1. So x plus y, the intercept is 1, 1. So I have taken this. And over here, the intercept is minus 1 and 1. So we have taken it on the other side. We want to find the area bounded by these rays and the x-axis. That means area of this triangle. Wherein our point here is 1, 0. And over here it is minus 1, 0. Because that's what the intercepts are. Minus 1 and 1 over here. And for y it is 1. So the area is half base into altitude. Half base into the altitude, OA. Now the base is 1 unit on this side and 1 unit on the other side. 2 units. Altitude is 1. Area of the triangle formed here is 1. In this question, we want to find area bounded by curves, both of which are parabola, and area is given 1, we have to find A. So if standard equation of parabola is given, then the area bounded is 16 by 3 AB. Now the parabola given here is y square is equal to 1 upon ax and x square is equal to 1 upon ay. Compare the value and write the area. 16 by 3 is going to be there. What is our A? 4a is equal to 1 by a. So a is 1 upon 4a. And same way, b will be 1 upon 4a. So 16 is going to get cancelled. We have 1 upon 3a square, and in the question the area is given as 1. So our value is 1 by 3 is a square, and a value is 1 upon root 3. So here we have to solve a differential equation. 2x dy by dx equal to y, which is variable separable. We will put y term with dy and x term with dx. Let 2 be here. Now integrating both the side. Integration of dy upon y is log y, and this is log x and plus c. So it becomes log y square is equal to log x. Rather, we will write here log c. So we can combine it and write log xc. xc. Removing log from both the sides. So y square is equal to xc is a parabola. We need not substitute this value also. Without that also we know it is going to be a parabola. Okay, this is a question of application of derivatives, and it is given that population of a city increases. So let's say dp upon dt increases with respect to the population obviously, but over here we could directly write it as given 3%, so 3 upon 100 p. Now we'll put p with dp, that is it is a variable separable again. So we take it here and we integrate both the side. This is log p and this is 3 upon 100 t plus we will write log c. So in order to simplify this, we'll write log e raised to, because our option has e raised to terms, that's why, plus log c. So it's log p is equal to log c e raised to 3t upon 100. Removing log from both the side, we'll have p is equal to c e raised to 3t upon 100. So those were questions of calculus. Now in the next video, I'll be taking up questions of relation function and inverse trigo.